And so it is. Hey, everybody. Hopefully lunch was satisfying, but not nearly as satisfying as this lesson's going to be. So let's talk about object relationships. So we should be getting a little bit more comfortable at this point with the idea of keeping state and behavior together. Well, I'm an owner. I have a name, I have an age, I have an address. I got lots of things that sort of describe me. So in my class, my owner class, this is the blueprint for how you make an owner. And I might have some behaviors that are like, say hey. And we could imagine how we would do that with something like a dog class. Probably works kind of the same way. Dog, maybe the dog also has a name. Maybe the dog has a breed. Maybe it has a variety of other things that are also part of its state. And it might have some behaviors too, like it can bark.
Gosh, dang it.
You all right? So we can do these kinds of things just fine. Now the power of object-oriented programming is combining these two things. So maybe part of my state is also that I have a list of dogs. And maybe I also have behaviors that let me add dogs, remove dogs, whatever else. So now these two things have a relationship. We say that, all right, well, this dog can get added to an owner, can get removed from an owner. We've got two different classes we make two totally different objects with, but they can send each other messages, they can be added to each other, removed to each other. So this is the sort of object relationships.
Hey, really quick back on that. So like when you add a dog to an owner, does the object owner, like, is that, what does that look like to the computer? Is it just its own object, or is it like an object of an object?
Ooh. We're going to put a pin in that one. What does it look like to the computer? It's a great question. But first, I want to introduce you to this idea of ERDs. There's two main relationships that we're worried about right now. If I have a dog and I have an owner, we say that these two things are entities, nouns. Sometimes they're like real actual things, like dog and owner. Sometimes they're a little bit more abstract. Like if you'll think back on day 2, we had the dog owner. That's not a physical thing, still a noun. So these are our entities, and we need some way to describe their relationship to each other. So we might say that one owner, one, has many dogs, but each dog can only be owned by one owner. That's what that thing right there reads as. One owner can have multiple dogs, but each dog is only owned by one owner. We call that a one-to-many relationship. And you write it like that, 1:M. One-to-many relationship. We could do the opposite of that if we wanted to get weird with it. We could say that one dog has many owners, but each owner can only have one dog. Wouldn't make that much sense, but we have the freedom to do this. We can model our problem however we want with code. So that's one kind of relationship. The other kind of relationship would be dog, owner, and we might say that one owner can have more than one dog, and each dog can have more than one owner. So we call that a many-to-many relationship. Common question, why is it MN instead of MM? Kind of a mathy thing, but MM would imply that they're the same thing. So MN is just implying that they're not the same thing. That's a more complicated relationship. We're not going to worry about that one today. All we're going to worry about is this one right here, one to many. This diagram is called an ERD, entity relationship diagram. What are your entities? What relationships do they have with each other? Who owns what, basically? So let's see what this looks like in code. If I make something called simple dog owner. All right, nothing up this sleeve, nothing up this sleeve. I'll make another app.rb file. I'm going to make a dog RB file, and I'm going to make an owner RB file. I'm going to open up my app. We'll do our require pry dance. We'll, get those two classes in there. And then we'll throw a pry in. If I go over to the dog class, say class dog. If I go to the owner class, that one's class owner. All right, so we have our entities in place.
Hey, Kyle, I'm sorry. Do you want us to code along with you or just
Nope.
watch?
I want you to just watch for right now.
Thank you.
You'll get hands-on in a sec. So I've got these two classes here. If I want to be able to add a dog to an owner, I could say def add dog. It's going to take in a dog, and then it needs some way to keep track of what dogs it owns. All right. So pop quiz, is that going to be an instance variable or a class variable that I'm keeping track of my dogs in?
Class variable.
Class variable, why?
Because you want to go ahead and access it throughout the entire class, whichever method that you want to use on it.
Okay, let's think through that. So I make an owner, and then I make a dog, and I say Kyle.add dog Bixby, and then I want to be able to, like, let's say I have another dog, Mesa. So I add Bixby, I add Mesa, but if it's a class method, then I go dog.dogs, dog.all. But here's where this gets tricky. Maybe I make another owner. Lisa's an owner too. These two are my dogs. Elise has a dog named Harmony. These up here. Okay, so if I do something like dog.all, and I was keeping track of all my dogs, I get Bixby, Mesa, and Harmony back. But I want to be able to know who are Kyle's dogs, who are Elise's dogs. So
Dog.kyle.all?
Ooh, interesting. Dog.kyle.all. So what this is going to look for is a method on the dog class called Kyle. And then whatever that returns, it's going to look for a method on that called all. So that would be something like def Kyle. Kyle is a new owner. And then I would return Kyle, and then Kyle would have to have an all method. That's how that would read. Call the Kyle method on dog, call the all method on Kyle. That's probably not what I want to do.
Could you just say like, Kyle.all?
So if I said Kyle.all, that would say, all right, I'm looking for an instance method on the Kyle object called all. And what's that going to bring back? Well, we could do that. We could say, all right, so here's Kyle is an instance of owner. So if we go over here and say make an all method, I could return something there. That's legit. Any other thoughts on how I could do this?
Dog.owner.all. That way you would be able to access all owners from
So,
the dog that are classified as such.
so this is going to say, on the dog class, call the class method owner, and then on whatever comes back from that, call the all method on that. Probably not what we want to do either. Any other ideas?
What if you did dog parentheses Kyle.all?
Like that?
Yeah.
So this is saying take a method called dog with a capital D and pass it whatever comes back from Kyle.all. That's probably not going to work because dog isn't a method. Dog's a class. So I can't invoke it directly. And I don't know what Kyle.all would be just yet.
Would you mind typing what we're trying to do with this real quick so we can just see what it is?
I want to track a list of each owner's dogs. So I want to be able to keep track of who owns what dogs, and I want to be able to list
So then don't we need to make an instance variable that would be an array that we can put each of the dogs into?
Hell yeah. Absolutely. So if I'm going to have this add dog method, I need some array that I can like put that dog in. So how do I do that?
You could make an instance variable in your initialize that would be an empty array to start.
Cool. So now I have an instance variable called dogs. It's currently an empty array. So then how does add dog work?
Do at dogs and then shovel dog.
Phew! Awesome. I am now keeping track of dogs. Pretty cool. So, I'm tracking each owner's dogs. Go to this next one. How do I list every dog that a particular owner has?
You would do a reader for dogs.
Like it. Something kind of like that. Let's see if it works. I should be able to do Kyle.dogs and get back Bixby and Mesa. I should be able to do Elise.dogs and get back Harmony. Kyle, who are your dogs? You're goddamn right they are. Elise, who are your dogs? Not one of those two, that's for sure. All right. That is as minimal an example as I can think of demonstrating object relationships. Dog doesn't need anything. Owner, one owner has many dogs, so we keep track of it there. These are the dogs that I have. There may be none, there may be one, there may be 1,000 of them. I can add new things to it with this method. And I can get back the ones that I own with that method. Ask me some questions about that.
So you can actually, so you're accessing owner.rb, saying for individual owners, whenever you go to like your app.rb, is that where you listing like, you creating, so you have 2 owners right now?
Correct.
So every time you want to go ahead and access what kind of dogs, how many dogs Elise have, you just say Elise dad, what was it?
Dogs.
Dogs, okay.
That'll return back all of Elise's dogs because that's what the reader does.
So if you give the dog, if you give the dogs an owner variable or an owner attribute, and then when you initialize or
Sure.
when you make the object of the dog, you have to say who the owner is.
Ooh,
And when you make that dog, can you call the method that adds the dog to the owner in that
I see what you're saying.
place where you're creating it?
So this would be a completely different design, but
Yeah, it's adding
it would
to the other side as well.
this would probably work. So let's do it this way. Let's see what would happen if we tried doing it from the other direction. When I make a new dog, I say who their owner is, and then from the owner side, add dog, let's see, is going to, let's see, how would that work? So I take in an owner, I say this is my owner, I can see that owner from the outside, and then I would say dog.owner, maybe like dot own, and then pass myself. Yeah, that's exactly how that would work. You'd say something like dog get owned. And then you would say something like my owner, call my owner, add dog me. You do it that way.
Okay.
Super backwards though.
Yeah, but it would do it to both, right?
Yes. So that would keep those together. So you could say like, yo, Bixby, who's your owner? And like we could find out. Yo, hey Kyle, who are your dogs? We could find out. That would do it from both directions. But In this one-to-many relationship, in most of those, you're only doing it from the one side. That's more common. We'll have to do this from both sides when we start doing many-to-many relationships. But for right now, don't worry about that. Other questions about one-to-many relationships and how they work?
So you're creating the dogs at dogs array when you initialize, so you
Yes.
have the capability to add dogs in there,
Yes, correct.
and then you create the instance method just to shovel in whatever dog.
Correct. But I can make all these new objects and then call that method to establish a relationship. That relationship, it's just shoveling stuff into an array. What else?
Can you go back to your app.rb again?
Mm-hmm.
Are these working in tandem because you have the dog folder and the owner folder? Like if you didn't have the dog folder, which doesn't seem to have much in it currently, would you be able to create that dog instance?
Let's use the right word. It's not a folder, it's a class.
File.
So
Right there, yeah.
Class. Yeah, the class doesn't do anything.
Okay.
That's not nothing though. Because I can still, since it's a class, I can still call dog.new. It'll still make me a new object. The object just doesn't store any state and doesn't have any behavior. But when I look at these, hey, who's Kyle or who's Bixby? No properties, no methods, but it's still an object.
So typically, would you still want to include things like the add at all in dog or anything like that so that you could track by looking at all the dogs, or is that just unneeded functionality?
It's not needed right now.
Okay.
But like, it's not off limits. Other questions? Cool, your turn. So let's come up with a different set of nouns that have a relationship. Give me something. Give me a noun.
How about parent and child?
Cool. So parent can have more than one kid. Well, each kid can have more than one parent. Let's go with single parent. So you've got single parent. A single parent, one single parent can have many kids. Each kid only has one single parent. It's a little bit tortured, but whatever, sue me. So what I want you to do is I'm going to put 6 minutes on the clock. I want you to establish this relationship. So you're going to need to make classes for kid and single parent. You're going to need to keep track of an array of these things on the correct class. You're going to need some way to add one to the other. I'm going to give you 6 minutes to give your best shot at that, and then we'll talk about it. 6 minutes on the clock, and Geronimo, go for it. Three minutes. You get done early, see if you can add attributes to it. See if you can read the attributes through the relationship. 1 minute. All right, so I'd like you to give me a fist to 5. A fist means, what the fuck are we supposed to be doing? 1 is like, I really didn't get anywhere. 5 is, got it working. So throw up a number, hold it up. Oh, keep it up, keep it up. Keep it up, keep it up. Okay, very nice, thank you. So let's talk about how we would do this. So we'll call this one single parent household. Make an environment RB file. We'll make a single parent class. We'll make a kid class. So I have these 3 empty files right now. If I hop into my environment and require pry, binding.pry, require in those 2 classes. Order on those doesn't matter if you were curious. So I go into the kid class and just make an empty class. I can do the same thing with single parent. Come on, man. Cool. Should be good to go. If I try running this app now, what didn't it like?
Does it matter that you required parent instead of single parent?
Yes, it absolutely does. That'll do it. All right, we're in. So I can, Duncan is kid.new. Old man Cobley got hit by a train, so Elise is a single parent. Cool. That part works. That's the part we should be pretty comfortable going into this with. Now the relationship part, when I initialize a single parent, I also want to initialize a kid's empty array. The reason why is that one single parent has many kids. Since the single parent has those kids, they have this array. That's how those 2 things map together. One single parent has a bunch of kids. Almost anytime you hear plural, many, anything like that, like your brain should go array. We can store multiple things in like hashes and lots of other shit, but 9 times out of 10, array is what you want to store a collection of things in. All right? So then I need to be able to get things into that array. So I add kid, it takes in a kid, and I shovel them in. And then if I want to be able to read those kids, ta-da.
Would there be anything wrong with putting the kids in the array in initialize as like a parameter?
No.
If single parent's always gonna have one?
You could start with some kids. So we could say kids, or default it to an empty array. So if we did that, maybe Elise is single parent.new. Duncan is kid.new. And I could do something like that. That's totally cool. And to wit, if I say I'll I'll put Miles in here also.
Why do you put Duncan in brackets instead of like in a parentheses, like it's a?
Ooh. Who can answer that question?
Because it's an empty array.
Because we'll say array is the data type for that.
Right.
That is an instance of kid. If we look at the single parent class, I want that to be an array. So even if there's only one thing in it, I need to pass in an array. Now I could also pass in more than one, like that. But doing it this way, we should see that Elise initializes with one kid, Duncan, and then we could take Miles and call add kid and get that in there too. It works. Hey Elise, who are your kids? Oh, there's one. Psych, you got another one. Cool. Hey Elise, who are your kids? There they are. More questions about this?
Wait, so sorry, I'm still on the brackets thing. So Ruby arrays, they have to contain the same data type, or can they contain whatever?
They can contain whatever.
Okay, but we're like enforcing type on it in order.
We're saying it should be an array. If I pass this in, this is an array that contains Duncan. That's just Duncan. So let's say that we did that. And I do this, and then kids becomes the Duncan object. Well, the first time I try to add a kid, I'm shoveling this kid into the Duncan object, not an array.
Gotcha. Okay, cool. Yeah.
So that's why, even if there's only one thing in there, when I do this, it's got to be an array.
And that's just because you put the ability to add a kid into the initialize statement, right?
Well, and like the premise here is that the single parent has more than one kid. More than one equals array. So even if you weren't able to add them, what I'm expecting is that single parent.kids gives me back an array, even if there's only one thing in it. Even if there's nothing in it. .kids should still give me an array. Ask me more questions. Two more things I want to show you with this. One is if we initialize kid with some kind of attribute of a name. That's also a thing that we should be pretty comfortable with. If I want to be able to read the name, I make an adder reader for it. That's also a thing we should be pretty comfortable with by now. All right, so then over here, when I make these new kids, I also have to give them names. Cool. So if I want, for any particular single parent, when I do .kids, I get back an array of those kid objects. Watch. Elise.kids. Cool. It's an array of objects. If I do Elise.add kid, throw Miles in there too. Cool. Elise has an array of objects for kids. That's fine. But let's say I wanted an array of the names of the kids. How do I do that?
Did you need a new instance method for that? That just like
Yeah.
on
It's
the
a
names.
new instance method. What's it called?
Kid name.
Kid names. Okay. What does it do?
So should we create a new array, or we could just map it, I think?
We can just map it because we're taking an array of kid objects and turning it into an array of names. If there's 5 kids, it should be 5 names. So that's a map. All right, so I kids map, and then what do I do next?
Do.
Do,
Actually, could we use the pretzel here?
should we what?
Could we use the pretzel thing here?
We can use the pretzel thing here. Let's do it the long way first, and then let's change it to pretzel.
Okay.
What goes inside the pipes?
Kid.
Cool. What goes in here?
Kid.name. Or kid.name, is it?
Nope, that's it.
Cool.
Awesome. Let's see if it works. So I do this, and I do, hey, Elise, why don't you add Miles in there? And hey, what are your kid names? Hey, it's an array of strings. That's what kind of like joins together these 2 different things we've been doing in Ruby all week. We've been doing lots of stuff with enumerables, your maps, your selects, your reduces, this like kind of procedural programming logic thing. Now we're talking about nouns and how they relate to each other. They seem like they're kind of different things, and they really are. This is where they intersect. We can do all of those kinds of enumerable operations on objects also.
We do that, and like you say at kids.map,
Yeah.
open parentheses, and the name thing.
These 2 things are the same. As is all 3 of these are the same thing.
Do you still have to add a map to the one with the pretzel?
Oop. It's like pairing with a bunch of people. All those are the same. Let's prove it. Hey, what are your kids' names? Still works.
Could you pull up the kid class real quick?
Yeah.
So why didn't we start with giving? Why doesn't a kid have a parent yet?
Because we can't access it the other way. All we can do right now is say, hey, single parent, who are your kids? We can't yet say, hey, kid, who's your parent?
Okay, but presumably, like, if there's any connection in our like database drawing, eventually that implies that you'll be able to get to parent from kids, or is that in the like terminology of like one to many somehow?
Sure. That's what we're going to do right now. That's the last thing that I want to show you for a cut you loose. So we can say, hey, Elise, who are your kids? But we can't say, hey, Duncan, who's your mommy? So we say parent, make an instance method here. So we could do something, I forgot who it was, mentioned at the beginning of this, was like, okay, so we add it to the single parent and then we also add it to the kid. But the problem there is now we're keeping track of the same data in two different places. So whenever I add something, I have to add it in two places. If I take it out, I have to take it out in two places. Oof, not good. So we want a single source of truth. This is like, that's probably one of the last big heady concepts that we do in Mod 1 is hammering home single source of truth. Any piece of data should only have one place that it exists. So right now, that's this kids array. We are shockingly close to being able to get any kid's parent. Can anybody piece together the logic on how we would do that? We need to add a couple things, but not many. We've done them before. We've done everything we need to do to get a kid's parent.
We need a parent instance attribute.
Parent instance attribute? No. We have this method here. That's what's going to do the calculation that's going to tell us who our parent is. Good guess, though. What else?
Are we going to look through our parents in order to find the string that matches the name?
Oh, that was like 90% of the way there. It's exactly what we're going to do, except we're not looking for the string of the name to match. There's more than a kid in the world named Duncan. There's more than one mommy named Elise. We don't want the string to match. What do we want to match?
The instance.
The instance. So we're going to look through all of the, like the parents' kids and shit. Let's try it. So if I'm keeping track of everything, we know how to do that. How do we do that?
Add it all.
Add it all. And then what does add it all start as?
Empty array.
Empty array. And then how do I keep track of everything?
Shovel the kids.
Shovel the kids! Hear that, Duncan? He's downstairs right now. All right, so now I'm keeping track of every parent that gets made. So what I want to do is get a parent that has me as one of their kids.
Would that be a find over the parents?
That's exactly what I think. So we do parent.all, which reminds me what?
We need a reader for the all in parents.
I do.
Single parent.
For a single parent. There we go. Thank you. So I'm going to do a find on that. The singular of this is going to be single parent. Okay. How do I know that I found a match?
Self.
What about it? That's one of the ingredients.
Would it be single parent include self?
That's another one of the ingredients. Single parent is one of them. Include is part of this. Self is part of this. We're missing one more ingredient.
Kid.
Kids. So, hey, single parent, why don't you give me a list of your kids, and I want to return whether or not that list of kids includes, I think include in Ruby has a question mark on it, I'm pretty sure. Ruby include.
It does.
Yep. Hey, single parent, you know that list of kids you have? Does it include me? And that's what find is looking for. Find is something that returns true or false. Let's see if it works. All right. Elise, who are your kids? Duncan. Duncan, who is your mommy and what does she do? Well, she's a single parent that has one kid. Boom! Yo, Miles. Yes? Who's your parent? I don't have one. Well, we're going to fix that right away. Hey, Miles, who's your parent? Oh, awesome. So we didn't have to track the parent in this kid class. We were able to calculate it because that information is all right here. Ask me some questions.
Can you go back to the single parent.rb?
Can you is it possible to do the all method as an accessor, or can you not because it's a self? Okay, but anything itself, it's no.
Right there. So adder reader is a macro, as is adder writer and adder accessor. They just generate those functions. There isn't a built-in one that does those with class methods. I don't think that's impossible or anything. I think it just Ruby doesn't ship with that. What else?
Can we see what kid looks like again? Sorry.
No problem. We got every parent, and we looked through all of them for the one that has a list of kids that includes me. Get the parent that has me as one of their kids. We didn't check to compare names. Kids and parents have same names all the time. We want the actual instance of it. All right, I think you guys have study hall right now. Again, like I know we're undoing anywhere from like 10 to 20 years of school. You guys don't have to come to these. I understand that you might want to. They rock so hard. You don't have to go to study hall. If you want to watch videos, you want to do those kinds of things, you are absolutely free to. If you get halfway through a lesson and you're like, this is not the best use of my time right now, it hurts zero people's feelings if you just leave. You have like an unprecedented amount of control over your education. So while we're certainly flattered that we see all 17 of you in every lesson, just remember that it's not required. And a lot of times, like, you'll have a better use of your time that doesn't involve going to a lesson. And like, these aren't one shots. We can talk about one-to-many relationships again on Monday and Tuesday and Wednesday. You just got to ask for it. So without any further ado, thank you very much. Have a good time in study hall.